Pluto, the mysterious dwarf planet on a potential collision course with Neptune. Pluto, the baffling dwarf planet located at the far edge of our solar system, is once again stirring interest within the scientific community. Recent reports indicate a potential orbital encounter with Neptune, raising serious concerns among researchers and space enthusiasts alike. Renowned experts, including Neil deGrasse Tyson and Michio Kaku, have voiced their concerns about the possible outcomes of this celestial interaction. But how did Pluto reach such a precarious trajectory? And what could this cosmic event mean for us here on Earth? Once considered the ninth planet, Pluto was reclassified as a dwarf planet due to its irregular orbit and small size. Despite this change in status, it continues to captivate astronomers. Ongoing predictions from prominent scientists suggest an alarming proximity between Pluto's orbit and that of Neptune. Experts warn that a future collision could have profound implications not just for the outer solar system, but potentially for Earth as well. Pluto's journey around the Sun is extraordinary. Its orbit spans 248 Earth years, and since its discovery in 1930, it has yet to complete one full revolution. Unlike the nearly circular paths of the major planets, Pluto follows a highly elliptical orbit that is tilted 17 degrees to the ecliptic plane. One of the most striking aspects of its motion is that it intersects Neptune's orbital path. For approximately 20 years during each orbit, Pluto actually moves closer to the Sun than Neptune, defying the expected order of planetary distances. So why hasn't a collision happened already? The answer lies in gravitational mechanics. Soon after Pluto's discovery, scientists realized that its orbit didn't behave like those of the other planets. It was inclined, eccentric, and most notably, it crossed Neptune's path. Yet, despite all these factors, Pluto's orbit remains remarkably stable. This is thanks in large part to a complex interplay of gravitational forces, known in physics as the three-body problem, which involves calculating the gravitational interactions between three massive objects, in this case Pluto, Neptune, and the Sun. Specialized phenomena like libration help explain Pluto's stability. Libration ensures that when Pluto crosses Neptune's orbit, the two bodies are never in the same place at the same time. In fact, Pluto is always at least 90 degrees away from Neptune during these crossings. This built-in cosmic buffer prevents a catastrophic encounter. Another concept, sometimes referred to as orbital resonance, also plays a critical role. Pluto and Neptune are locked in a 3:2 resonance, meaning Pluto completes 2 orbits around the Sun for every 3 of Neptune's. This synchrony ensures that, despite appearances, their paths never truly intersect in a hazardous way. Yet there's a deeper layer of complexity. In the 1980s, computer simulations revealed something unsettling. Pluto's orbit is technically chaotic. This means that even minuscule changes in its initial conditions, its position or speed, can lead to vastly different paths over millions of years. And yet, despite this chaos, Pluto's orbit remains stable over incredibly long timescales, thanks to the stabilizing influences of Neptune, Jupiter, and Saturn. Jupiter's immense gravitational pull, combined with Saturn's subtler influence, acts like an invisible hand, keeping Pluto in check. Together, these forces form a dynamic system that safeguards Pluto's journey around the Sun and prevents orbital catastrophe, for now. Understanding these orbital mechanics is more than an academic exercise. If anything were to disrupt the delicate balance, say, a rogue planet or an unknown gravitational influence, it could send Pluto on a collision course with Neptune. Such an event, although unlikely, would be catastrophic. Neil deGrasse Tyson, known for advocating the reclassification of Pluto, sees this debate as a gateway to deeper understanding. For him, Pluto's odd behavior and potential threat are not just fascinating curiosities. They are windows into the vast and complex forces that shape our solar system. Tyson often highlights that our knowledge of the universe is constantly evolving, and that Pluto's story is a reminder of how little we still truly understand. Michio Kaku, a leading theoretical physicist, echoes this sentiment. He views the study of Pluto's orbit not only as essential to celestial mechanics, but also as a way to test theories like string theory and quantum gravity. A potential Pluto-Neptune collision, while disastrous, could produce extreme energy and gravitational conditions, an unprecedented opportunity for scientists to gather data that might illuminate the fundamental nature of matter, space, and time. Kaku notes that gravitational waves resulting from such a collision could ripple through the solar system, offering insights into the deepest laws of physics. Although Earth would likely remain physically untouched due to its distance, the scientific data gathered from such an event would be invaluable. In the broader context, Pluto serves as a symbol of both stability and fragility in our cosmic neighborhood. It shows how planetary orbits can be simultaneously chaotic and orderly, unpredictable, and yet deeply governed by natural laws. The so-called three-body problem, exemplified by Pluto's relationship with Neptune and the Sun, is not just a mathematical curiosity. It's a key to understanding how the universe maintains its structure. And Pluto isn't alone. In other systems, like the tightly packed TRAPPIST-1, planets orbit in such close harmony that even small gravitational nudges could push them into instability over time. Yet collisions are rare. Nature, it seems, has ways of preserving balance, even in crowded orbits. Then there are the rogue planets, worlds that drift alone through space, ejected from their home systems by violent gravitational disturbances. If one were ever to enter another planetary system, a collision could occur. But the sheer vastness of space makes such encounters extremely rare. Even so, the possibility remains. As we learn more about these cosmic wanderers and the forces shaping planetary motion, we move closer to understanding the hidden mechanics of the universe. The case of Pluto, its strange path, its unlikely stability, and its potential for chaos, stands as a vivid reminder of how dynamic and interconnected our solar system truly is. We live in a universe filled with uncertainty and wonder, where even a small icy world like Pluto can pose monumental questions. Whether or not it ever collides with Neptune, its orbit will continue to teach us about gravity, chaos, and the breathtaking complexity of space.